Alright, as already mentioned, the Spark Streaming Library is very popular, as it's what turns big data into fast data, and it has its own diverse ecosystem. For this course, we only have time to give you a sample of its capability, leaving the deeper dive for the follow-on Handling Fast Data course already mentioned. The project we'll use will show the word count of streaming, using the Twitter firehose and counting up the number of hashtags during a given window of time. So, in order to follow along, you'll first need to get access to the Twitter API by going to developer.twitter.com/apps and clicking the Create App button, filling out the required information, and accepting the developer agreement. Once created, you can go to your new app's Keys and Tokens section and click on the Generate button. Make note of the tokens, as you'll need them to open the application's own stream. But first, let's see what we need to put in our build file to create a standalone streaming application. At minimum, we need to include the Spark streaming dependency. However, since our application will be using streaming's Twitter-specific library, we also need to include that dependency, as well as its transitive dependency on Twitter4j's stream library. Note that the dependencies that aren't part of Spark Core or its direct libraries are not marked as provided. That way, they'll be added to our Uber jar. And, along those lines, the last necessary configuration is to set up SBT Assembly's merge strategy so that, when building the assembly, if it encounters duplicate files, it'll pick the first one per class path order. With that setup out of the way, let's review our setup code. First, notice that we're importing everything from the Spark Streaming and Spark Streaming Twitter namespaces, giving us access to the streaming-specific objects. And we'll also import Twitter4j's status, as that is what we'll be streaming, the flow of user statuses. Then, the first thing we do in our code is set our Twitter access tokens in the system properties, using the tokens we created earlier. They'll be used to create the OAuth credentials necessary for opening the Twitter hose. Next, we create our context just as we've done before, and pass that context into the streaming context constructor, which we could have simply passed the conf directly in, letting the constructor create the core context for us. And the other constructor parameter represents the duration of time for which our stream of data is batched into RDD chunks. In fact, that's the name of the type it accepts, a duration, which is your typical time object, representing the time in milliseconds. However, instead of having to write everything out in milliseconds, there's also these nice helper objects for easier and more explicit time representation, ranging from milliseconds to seconds to minutes. Time intervals beyond that start to beg the question as to whether you're really streaming. Next, as the primary method we'll be using, count by value and window, is a stateful operation, we're required to set a checkpoint directory for our streaming context, where checkpointing is merely a periodic sync to reliable storage with our current state. It's required here because stateful methods are driven by an RDD relying on a chain of previously batched RDDs. This dependency graph could grow so long that recovery time would get slower and slower as the originating point of reference grows further away. Checkpointing merely acts as a reset for that origination point. It's also needed if you require failure recovery for your driver program, but that's a topic for a future course. Now we're ready to bring in our stream, and we'll use Twitter utils to do it, the object brought in by our Spark Twitter dependency. Through this object, opening a Twitter stream becomes as easy as calling its createStream method. In fact, there are a number of other sources just like this one, such as Kafka or Flume to name a couple, and all follow the same naming pattern for their dependency and object. The createStream definition we're using takes in our streaming context and an optional Twitter authorization. If you don't supply a prepared authorization object and pass in a none, as we've done here, then one will be built for you, using the authentication values that were placed in the environment earlier. Then, once we have our initial Twitter dstream, we can begin working with the data in just about the same way we're already used to, pulling out a list of hashtags in each incoming tweet, and flattening it all into one list through the flatmap method. But there are, of course, some differences when working with streaming data, like working with a period of batch data, manipulating it in a stateful manner. These windows of data require new methods, such as reduce by key and window, or count by value and window, which we've used here. The first duration parameter is the time window determining how long batches are stored for counting, while the second duration is the frequency with which the calculation is executed, known as the slide. As these durations directly relate to each of the incoming batch, they therefore must be a multiple of the context batch duration. I'll go over this sliding window concept more concretely once the code is set in action. But first we need to massage our dstream a little more, as the count returns a pair with the key being the hashtag and the value being the count. So first we'll reverse that, making the count the key. And then we use the transform method to sort by that count, putting the topmost hashtags at the top. This transform method is like a special map for streaming. It exposes the underlying RDD so that you can work directly with it, returning the transformed RDD to be wrapped back up as a new dstream. At that point, we'll finally call an action, referred to as an output operation in streaming. This print output method we're using here is like the show method on a data frame, printing the dstream items to the console, where 10 is the default if not specified. It's more often used for debugging, but there are a number of output operations for persistence, such as save as methods, or there's a more generic for each RDD method, which is just like the transform method, except it's an output operation, returning unit to cap off that flow of the stream. However, keep in mind that these final operations will execute each time a window is encountered, or batch if not windowed, and could lead to file overload if not persisted with this constant flow in mind. And another item to note about dstream operations is that, unlike other components of Spark, none are eager, even the output operations. There's still the conclusion of the dstream setup, but they won't come into play until the stream receiver is started, accomplished by calling the start method on the streaming context, which will throw an exception if there's no output operation configured for it. Note that this method will return immediately, so to keep our program from reaching the end and closing before it can even get off the ground, the context provides us with a helper method named await termination. This call is exactly as it sounds, blocking until the streaming context is stopped. With that explained and the jar assembled, we can start via Spark Submit. Once submitted, the code will build up the lineage and start our Twitter receiver. Recall that our batch interval was every 5 seconds, but our sliding interval is every 10, so we don't get any output until the receiver has accrued at least 2 batches worth of data. However, our window duration is every 15 seconds, meaning that our count will evaluate against the last 3 batches of data max. Our first output is only 10 seconds of total data, since that's all that's available at that slide. However, the next slide at 20 seconds will only calculate against data accumulated between 5 to 20 seconds. At 30 seconds, the count evaluates again, only using the 15 to 30 second data. We can see this when 2 values have dropping counts between one interval and the next. Now, one final note before we finish streaming. Notice that, with a streaming receiver running, the Spark UI now displays a new section named Streaming. It provides graphs of the data flow and information for each evaluation of the dstream graph, representing each slide duration. Again, the details of this monitoring tool are covered in the follow-on Handling Fast Data course, but it's definitely something to be aware of and keep in your tool belt.